All right. Hey, I'm gonna go ahead and get started, Danny. I'll start with just some preliminary stuff. I really appreciate everybody taking the time out of their day today. I know everyone's eager to wrap things up and get the long weekend started. So I appreciate you spending your lunch with me. If I get booted for some reason today, give me 5 minutes to hop back on. We're all working from home. There's technical difficulties all the time. I don't foresee that happening today, but if it does, give me a few minutes to hop back on. If it happens more than once, we will reconvene. Again, I do not think that will happen today. Any questions? You guys should be able to unmute yourself and chime in, so feel free to ask. You can also wait till the presentation's over and get in touch with me. But I am going to jump right in. Danny, can you just chime in and confirm that you can, in fact, see my screen? We're good to go?
Yes, I can see your screen.
Okay, awesome. All right, guys. So modified bitumen roofing systems. We're going to talk about a simplified approach to commercial low-slope roofing today. My name is Hannah Safran. I'm part of the architectural representatives for Polyglass USA. If you guys are unfamiliar with Polyglass, Polyglass is actually the largest manufacturer of mod bit in the United States. We are best known for inventing the self-adhered product, which almost every manufacturer has one now. We can talk more details about Polyglass specific products at the conclusion of this if you guys are interested, which I sure hope you are. Today's presentation is good for one AIA Health, Safety, and Welfare credit hour. We are going to talk about the very basics of low slope roofing today. What goes into a roof? It's not just the top layer, but all of the components. We're going to talk about the various systems that are available on the market, and we'll specifically talk about mod bit and the evolutions that relate to the self-adhered products in particular. So the basics of low slope roofs. It's nearly flat, low slope. Water tends to drain very slowly. Drainage is arguably the most important factor of a low slope roof. You're dealing with larger panel sizes. Today we're going to talk about the roof on top of the insulation. There are inverted roofing systems, which you may be familiar with. We're not going to touch on that today. All the discussions will be based on roof on top of the insulation. Rooftop traffic is possible. It's very likely in any commercial scenario, you're going to deal with some kind of bi-yearly maintenance. And of course, if you're dealing with a rooftop deck, then you're dealing with heavy traffic flow. Often low slope roofs are for commercial use, but you see them all the time in residential roofs, you know, downtown Baltimore, DC, tons of flat roofs. Now modern single families have flat roofs, garages, various uses like that. So the components of a roof, I mentioned this, it's not just that top ply, it's everything that goes into the roofing system. So that includes the roof deck, your insulation, your cover board, and of course, your membrane of choice. So we'll start with the deck type. Various types of decks on the market, whether steel, concrete, wood, whatever it is, your deck type is the foundation of your design. It's going to influence how you meet your wind uplifts, your fire resistance, how you attach the remaining components of the system. So think of your deck as the basis of the rest of your design. Moving on from that, you have your insulation. Again, just like deck types, various types of insulation on the market. Each one is good for a specific system. Polyiso is the most commonly used. A lot of that has to do with availability. These factories are strategically located throughout the company, making it very easy to deliver. Also, polyiso is compatible with most of the components that you'll come into contact with. So, and R value is a big reason why we're using ISO. You'll get a high R value per inch by using polyiso. I think it makes up like 60% of market share when it comes to insulation. Continuing on insulation is your cover board. Again, various types of cover boards out there. Biggest reason you would use a cover board is really manufacturer preference. If you need it as part of your warranted system, well then yes, you want to use it. It's never a bad idea to have it. It's going to give you good dimensional stability, and it'll give you a great working surface, a nice smooth surface to attach your remaining layers. And then the different systems that are out there. So you have your structural metal panels, your liquid applied systems, SPF, your asphalt-based products, which include built-up roofing, and then your modifieds, APP and SBS, and then your single-plies. EPDM, PVC, TPO, the most common. That's what we'll touch on today. Before we get into the details of your low-slope systems, let's talk about a couple design challenges that you'll run into. There are tons. So when you are approaching every job is super unique in the sense of, hey, is this in a hail-prone area, or is this in a heavy wind area? Is it in Florida? Is it in New England? Every job is super specific. So a couple things we're going to touch on that you can relate every job to. When you're dealing with a low slope roof, as I said before, drainage is super, super important. So ideally, you're building the slope into the structure, but also you can create positive drainage with the use of insulation by creating a tapered design. More on insulation, R value. Most of you are probably familiar with R value. Those that aren't, R value, think of it as resistance, thermal resistance. It's going to resist the transfer of heat, for instance. So R value varies based on where you are building. So just be aware of that depending on whatever job you have on hand. How are you securing your insulation to the substrate? Various ways to do that. And this might be influenced by your manufacturer of choice. It might be influenced by what code approval you are trying to achieve. But regardless, if you're going with an adhesive, whether it's asphalt, foam, glue, just make sure it's compatible with everything it's going to come into contact with. If you're going with a mechanically fastened system, you want to make sure that you're using the right type of fasteners and the right amount of fasteners, which will vary dependent on where you're building, how high the building is, what kind of wind uplifts you are looking to achieve. And a ballasted system is going to add some weight probably to your system. So you want to make sure your deck type is foundationally sound and can withstand any added weight. Code approvals. Are you dealing with an FM insured property where you need an FM approved system? If so, you want to make sure that your manufacturer complies with this. UL, down in Florida, you have probably the most stringent codes, Miami-Dade. Do you have a LEED building that you need to meet? So various approvals out there. And of course, I'm always a resource if you guys have any questions regarding how to meet these specific criteria. Design considerations, they're regional. Any job that you're doing down in Florida or up in New England, again, it varies so drastically. So every single job needs to take a specific approach. Hail, here's a little warning thing. Here in the Mid-Atlantic area, we're not dealing with crazy hail here. But this is an aged PVC. The picture here, it's an aged PVC. As PVC ages, those plasticizers will start to migrate away from each other, and it leaves it brittle. So hail hits it, and all of a sudden you have these spiral fractures throughout your entire roof. So you just want to make sure whatever system you are going with can withstand the elements that it's expected to face. You guys might recognize this here, the Louisiana Superdome. This wind was obviously the cause of, Hurricane Katrina. I think that was 2013 or 15, maybe 2013, I think. But yeah, so wind damage. The alleged failure of this roof was insufficient fasteners and insufficient heat welding in the seams. So really, this is kind of just a warning slide of how important it is to have a roof observer on the job to make sure that, the right amount of fasteners are getting in there and the seams are done properly. And who knows if that could have prevented this. Obviously, this was a crazy storm, 125-mile-per-hour sustained winds, but that was the outcome of the investigation. Energy, cool roofs are a big thing. I wanted to point out these two websites. Coolroofs.org is a great one. You might have a TP roof that you want to use, and the SRI, year one, it's super bright white. But what does it look like after year 3? So coolroofs.org is a way you can check that out for various manufacturers to see how the products age over time. And then energy.gov is great for checking local utility credits. You might be able to save your owner some money by checking that website. LEED. Under the new LEED, LEED V4, you can get 2 points for a highly reflective roof. Again, this is just being aware of what your owner is expecting out of you when it comes to these code approvals. So roof usage, is the roof an extension of the interior? Meaning, hey, is this going to be a traffic, is this going to be a walkable roof deck? The roof on the left here is a building in Chicago. Obviously, that needs a very special system. Big traffic coding needs to go down on that one. Where the roof on the right is more of your typical standard commercial structure. But even on that typical standard commercial structure, you're going to have your bi-yearly maintenance. You have all those skylights on there, those HVAC units. You might have an HVAC guy go on a roof and drop his toolkit. And if he drops a pair of scissors on a single ply, did he just cause your first leak? So you just want to make sure whatever you're putting down, it can withstand just the general abrasion that's expected to take place. Penetrations. This is just a heads up. When you're dealing with a roof on the left where you have a ton of penetrations, consider using a liquid flashings to get that monolithic finish. Get those areas that are tough to flash watertight. And then the picture on the right, when it comes to rooftop solar panels, solar panel installers are not roofers. So you want to make sure the way it's constructed is, hey, your solar panel guys are going out there first, and then your roofers will follow up and make sure that everything was flashed properly. So those are just a couple little warning slides, if you will, to consider. Again, you're going to consider a whole lot more than that on each job. Every job is super unique. So we'll get into the fun stuff now. The low slope roofing systems. So the first one is your structural metal systems, your standing seam roofs. These roofs are awesome. They're going to last you 50 plus years. The vertical seams are clipped together. They're mechanically clipped together. It's nearly impossible for water to penetrate those areas. Where you have issues with metal roofs is your horizontal seams. Metal roofs, of course, tend to expand and contract a lot more than any other material on the market. So where those horizontal seams, you're relying on some kind of fasteners, some kind of sealant, and of course you have your water barrier beneath the surface, some kind of self-adhered high temp underlayment, but that doesn't always cut it. So those fasteners and those lap sealants, they're maintenance items. So you might have a metal roof that's going to last you 50 years, but every single year you need to go out there and check those fasteners. As the roof expands and contracts, those fasteners start to loosen up over time. Your sealants will start to loosen up over time. Depending on what type of sealant it is, it might even degrade over time. So you just want to be aware of that when you're considering life cycle costs. Liquid applied membranes, I like to break it down. You got your JV and your varsity team. This is your varsity team. So you have, when it comes to your varsity team, you have a PMMA, you have a 2-part urethane. There's actually 1-part urethanes on the market as well now. And these products, they all go down in similar fashion. So you have a concrete roof. One option is to torch or self-adhere to mod bit base layer, and then you're going liquid fabric liquid. Sometimes you don't even need that mod bit layer. You can scarify the concrete, liquid fabric liquid. Essentially, just think liquid fabric liquid. These products in particular, these varsity grade products, they're used in new construction all the time. They're used in re-roofing all the time. They're extremely expensive. Depending on where you're building, you know, you'll see them go for $13 to $22 a square foot, depending on the area. So they're expensive, but they work and they last a very long time. What we see now is that a lot of people are going out there and they're specifying a 2-ply modified system, and they're specifying all the flashing in a PMMA or a 2-part urethane or a 1-part urethane, which again, liquid fabric liquid on all your pipes, penetrations, all your detail work. And what that's doing is those worrisome areas are no longer worrisome. You're putting down a bulletproof product in those areas. And that liquid is being warranted for the life of the membrane itself. So if you have a 30-year system on there, you know that liquid is warranted for 30 years as well. Your JV team is going to be your acrylic, silicones, urethanes. It's like a different grade of urethane. Again, coating, fabric coating, that's going to be the system. I wouldn't they can be used in new construction, but I wouldn't necessarily push this for new construction. This is more like if you have a university and you're building a new wing on a university, and while you're up there, they say, hey, we have this 18-year-old EPDM roof. Is there anything you can do? There's a couple leaks by the drains. All right, well, this is a good opportunity to use an acrylic or a silicone roofing product. You can patch up those areas that are leaking. You might cut out some, if there's water damaged insulation, you'll cut them out, you'll replace it with like materials, and then you'll put down a coating system, this JV coating system, and you can get warranties up to 20 years with them. SPF, not super popular really anywhere anymore, but essentially, this is a 2-component that sprays out, gets super hot when it goes to this exothermic reaction, blows up. You're getting your insulation, your R value, and your roof, your watertight roof system, all in one spray. And you do have to coat it. It's not UV stable, so you have to coat it with an acrylic, a silicone, or a urethane. The problem with this product is it takes an extremely talented installer to get it right. And then you really want like an orange peel finish. And if you've ever been on an SPF roof, most of the time you'll see like popcorn finish where it's just like up and down, and that's no good because you get a lot of bird baths. And all it takes is one little chip, and then the birds start coming and they chip away at the rest of your roof. So if you're going to go this route, you want to make sure that you have a very talented installer. Single-ply membranes, you guys are probably all pretty familiar with single-ply membranes. They are exactly what their name says they are. They are a single layer of defense, 45 to 90 mils thick. Most commonly, we see 60 mils on the market. They're often reinforced products, and they're wider sheets. 2 types of single-ply membranes on the market, your thermosets and your thermoplastic. Your thermoset is going to be your EPDM. This is a fully cured membrane. It's typically black, but the fact that it's fully cured means you can't put a torch to it and you can't heat weld it. So EPDM, and I've been on numerous EPDM roofs. I deal with a lot of coatings, and they're great to coat with your JV team coatings. But the reason is that the membrane itself is great. You can get on a 16-year-old EPDM roof, and all of the seams have all this goo on them because they've been patching them for years and years. But if you cut out those seams and roll up the middle of the membrane still looks brand new. So the membrane itself will last a very long time. However, at all of your details, you are relying on either mechanical attachment, or which means you're putting a hole in your single layer of defense, or you're relying on some kind of adhesive or tape. Well, adhesive and tape are temporary moves. They're not going to last forever. They need to be maintained. Hence why your issues with EPDM come with, with where all of your flashings are. When it comes to thermoplastic, TPO and PVC. We'll start with TPO. TPO is huge in new construction right now. It's a price point to an extent. However, when you're doing a Class A roof, you can do a 2-ply modified without a cover board and get a Class A system, whereas TPO requires a cover board. So TPO is actually in that situation more expensive. The material itself is super cheap, but a couple things you want to keep in mind with TPO. There is a fit for every product on the market, and when it's installed correctly, any product on the market can perform well. However, TPO ASTM standard just came into play in 2013, which required 30% of the good stuff has to be above the scrim. So 30% of a 60 mil sheet means you have about 18 mils of good weathering materials in a 60 mil sheet. Why does TPO fail? Well, it fails over time because it weathers away year after year after year. So when you walk on an old TPO roof, as opposed to an EPDM, like an EPDM, you'll see at the seams, they'll fail. Whereas on a TPO, the seams are heat welded. So if done properly, there's a small window to get a good weld on a TPO. But if it's done properly by a good installer, those seams are bulletproof. They're not going anywhere. However, where TPO fails is literally the middle of the membrane. And if you go on an old TPO, then you've seen how you can literally see the fibers of the mat exposed as it weathers away over time. So again, these TPOs are going on the market. You're offering 20-year warranties on them. But this new ASTM standard is not even 10 years old, meaning the newest products on the market have not even been around for 10 years. So all things to think about. PVC, your basic standard PVC has major temperature restrictions, and it can get super brittle, like in hail-prone situations or in the cold. PVC key, they throw in this key polymer and limits the amount of plasticizers, so it makes it a super durable product, and it's a very good product. But the issue is, of course, it's more expensive. Again, the biggest difference between these two products are going to be how you're approaching your seams. So your TPO, PVC, your thermoplastic membranes can be heat welded, which makes them bulletproof. Your EPDMs, not so much. You're relying on other things. How are you attaching these products? Ballasted. Obviously, if you're going with a ballasted system, you want to make sure that your deck can withstand that added weight. Fully adhered bonding adhesive. Well, we're dealing with VOC regulations changing throughout the country. Your new low VOC bonding adhesive, if you go out and ask any contractor about it, I have not heard a single one that likes it. So number one, it's a newer product, as opposed to your solvent-based bonding adhesive that's been used for years and years, and we know it works. But the newer bonding adhesive that's on the market, that's lower adhesive, it doesn't flash off as quickly, and guys just don't like working with it. However, everyone's going to adapt. It's going to be fine. But just know that we're now working with these new products that don't have a 20-year track record, and of course, we're often warranting these products for 20 years. And mechanically attached, I get iffy about this when it comes to single ply because I think it's interesting that you'd want to put fasteners through your only layer of defense. So that brings us to our multi-ply systems. Built-up roofing. Built-up roofing, anybody on this call, if you guys are all in the younger generation, then you might not even know about it. But there's probably somebody on this call that knows built-up roofing well. It is used in very few markets throughout the country. We are one of those markets that it's still used. It makes up a very small percentage of multi-ply of roofing, commercial roofing in general. But it was the basis of design for 100+ years. And if it is done properly, it is a very, very good system. So essentially what happens is you're using this asphalt or coal tar, you're putting it down, you're throwing in some felts, and you're repeating that process. So you're building the roof while you're on the roof. obviously from this, they wanted to take away a couple of those scary factors, and modified bitumen came out as an extension of built-up roofing. So APP and SBS membranes were developed in Europe in the 1960s. The idea was to make a pre-manufactured roll that you weren't creating, but you can get a multiply system. It's pre-manufactured. You know the width, the length, the thickness of it before you get on the roof. And we'll go ahead and get into ModBit systems a little bit more now. So typical ModBit system is going to be 2 or more plies. Your thickness is going to be 250 to 350 mils. Think about this. Your base sheet alone of a modified system, the ASTM standard is 80 mils. So your base sheet alone is thicker than majority of the single plies that are on the market. Base sheet alone. So you already have a thicker system just by putting down that base sheet. Base sheets are often going to be smooth. They'll get you watertight, and it'll give you that nice, clean working surface. Your cap sheets typically are going to be thicker, granulated. The granules will help with UV protection, aesthetics, and fire rating as well. So the benefits of a multi-ply roof, the benefits of ModBit is very simple. Think multiple plies means you're going to get more plies, more puncture resistance, more abrasion resistance, more strength. Because of the evolution of these products, there's now pre-manufactured end laps and side laps. It's just everything about these products has become, trying to simplify it. Manufacturers are trying to simplify it to make the install as easy and smooth as possible. And of course, the proven performance. ModBit itself has been out since 1960, but it is an extension of built-up roofing, which again was the basis of design for 100+ years. You're not going to have any catastrophic failures. If you have, like for instance, the Superdome, you're not going to get one big uplift of the entire roof. Also, a little pinhole in a modified, water doesn't like to change directions. So when you're staggering these seams, if you do have a pocket in a modified system, it would be tough for water to penetrate multiple layers. Yeah, so that's good. ModBit systems, you have your APP and your SBS. And I'm sure you guys are familiar with both of them. You have styrene, butadiene, styrene, and atactic polypropylene. The reinforcements are fiberglass or polyester or a combination of the two. APP and SBS, the biggest difference between these, now the traditionally APP weathered better you'd see it in warmer climates. SBS was made for colder climates. It deals well with thermal shocks. So actually places like Arizona, it does well, where it's super hot during the day and super cold at night. And these things are still true. However, the advancements of both of these products, they're so similar at this point that you can really get away with using an APP or an SBS in almost any situation, especially in the Mid-Atlantic region. The top layer of these APP or SBSs, you have your fabric reinforcement, and then that top layer will either be a smooth, which is often your base sheet or your mid-ply, or a granule finish or a film finish. So self-adhered systems, they can come in APP or SBS. The traditional way of making them was to spray a tackifier on the bottom of your membrane. So your APP or your SBS roll would go through the same manufacturing process, and at the end you'd spray on a tackifier. That's a whole lot like duct tape, where it's just not the adhesion that you really want for a commercial type system. So as the advancements came about, there's now this dual compound adhesive where you have a true APP or SBS on your top half of your product, and on the bottom half of your product you have a self-adhesive SBS polymer that the entire bottom half is a weathering / adhesive compound. So the more it stays on that roof, the stickier it gets. You're getting more and more adhesive. So 20 years from now, you're not getting that stuff off. Reinforcements. I just had a long conversation about this with a guy the other day. Fiberglass or polyester, and then of course the combination of the two. Frankly, a lot of it comes down to contractor preference. Fiberglass will give you more dimensional stability. Polyester is just a stronger material. So ultimately, polyester can be seen as the more advanced, the better mat. But ultimately, again, it really comes down to user preference. So install methods, APPs and SBS, you can self-adhere both of them, you can torch both of them, you can cold adhere both of them. You cannot mop APP. So if you are specifying a hot mop job, you would have to go with an SBS roll. The trend, you have built-up roofs. Again, been around since the 1800s. So relatively, mod bit is pretty new. But hot mopping came about in the 1960s. You then had your torch applications, 1960s, your cold adhesives in the 70s, and then your self-adhereds came into the US market in the late 1990s. So industry trends, conventional install, of course, was the hot mopping. For obvious reasons, this is phasing out. The odors, super labor intensive. As we're phasing away from that, it's extremely hard to find really good labor. And you could say the same thing about a cold adhered system or a torch down system. It's getting harder and harder to find dedicated, knowledgeable installers. No more heavy equipment. People don't like to use that. Those big kettles, you see the guy on the right pushing around. Environmental issues, VOCs are a huge issue. And insurance. Insurance is a huge reason why people are moving away from VOCs and from torches. So initially APP, heat welded, that's it. SBS, just hot asphalt, both. You can use on a torch now. But because of all these reasons, self-adhered is really gaining popularity, and you see it throughout the market. It's not just with roofing. And it's not just with modified. You see single-plies are now being self-adhered. Why is this the case? Well, super easy installation. You're seeing these pre-manufactured end laps and side laps. You can use a smaller crew to put them down. There's no smell, so no VOCs, no excessive noise. Very few tools are needed to put this stuff down. No flames, no kettles. So overall, it's a safer, simpler installation. There are limitations, but not so much anymore. So back in the day, there would be a limitation that, hey, you can only put down self-adhered products 40 degrees and rising. Today, most manufacturers have a cold product and a hot product. Your cold product will go down as low as 20 degrees. Just as long as you have a dry surface, you can put it down. So that's not so much a limitation anymore, but you just need to be aware if you're specifying a job that's going to happen 6 months from now, what product do you really want to look at? And do you want to maybe leave a segue there where people can pick and choose which product makes the most sense for the timing? It's not just a peel and stick. I think people get away with the fact that it's called a self-adhered membrane. You can't just peel off the backing and stick it down. You do have to roll each ply with an 80-pound roller. Very easy to use. You see a picture on the top there. A guy's using a handheld laser gun. It's a handheld heat gun. In some situations where you can't use that pre-manufactured end lap, you have to cut the rolls. And in those situations, you can use a mod bit adhesive or you can use a handheld heat gun. Very simple. You're just embedding that with heat or adhesive. But other than that, with the pre-manufactured end laps and side laps, this product is going down pretty quick. And as far as the tools go, you need that handheld laser gun, that roller, the 80-pound roller, a pair of scissors, and essentially you're good to go. Safe applications, no torching, no mopping, no VOCs, all that good stuff. This self-adhered products, if unfamiliar, they're going to go down to pretty much all your go-to insulations directly to them and also all your go-to cover boards. No issue with adhesive, with any kind of adhesion in most situations. Clean and neat application. One of the biggest complaints about Modified for a long time was that it's not a really neat finish. You have your bleed out lines, your footprints if you're doing a cold process application. Well, with a self-adhered, you're not dealing with that. You have a nice clean finish. You don't see any bleed out lines or anything like that. It does come in an array of colors. So if you want something crazy, you can get that done. Environmentally friendly, again, no fumes, odor. Most of the material is recyclable. So you take off the backing, they're packaged in cardboard boxes. You put the backing in the cardboard box and you toss it. So pretty simple, environmentally friendly, insurance friendly. Again, like I said, many roofers are just moving away from the flames, the kettles, to save money on insurance. Here's a picture of the granule-free headlaps and end laps. You see there's actually a pre-manufactured adhesive on the end laps and side laps, and there's actually third-party testing now that shows the seam strength, which I can provide if you guys are interested after the presentation, but the seam strength of a self-adhered product is actually superior to a cold applied, a torch down, or a hot mop system. So I think that's pretty incredible considering in a torch down situation you are welding these materials together. But again, the seam strength has been proven through a third-party FM test. Reflective surfaces, for a while TPO took a good grasp on the market because it was bright white and that was the thing to do. But now you see modified membranes across the market. Manufacturers are putting out these bright white modified membranes, whether it is a film finish, whether it's coated granules, whatever it is, there's bright white options on the market. Wind uplifts, fire resistance, warranties up to 30 years. You name it, these modified self-adhered systems can get the job done. So references, I just want to show you guys a couple buildings here that chose to go with the self-adhered system. This first one is in Mississippi. It is a hospital. Hospitals can't close their doors and they do not want to deal with fumes. So what they did was they went in section by section. They tore off the roof. They put down a self-adhered base layer. That base layer can be exposed for 90 days. So you can go through, it's watertight and it can be exposed for 90 days. So you can go through and do different sections of a roof or an apartment complex or whatever. You can do sections of it knowing that it's watertight, knowing that it's good to go, and then go back and do your cap sheet after all the other trades have destroyed your system. A high rise here. This was kind of about accessibility. So when you're dealing with a high rise building, lugging 10-foot single ply rolls can be kind of a headache. So they just put in these 1 square, 2 square cardboard box self-adhered products, put them up the freight elevator, and you have your product on the roof. An office building here. I think this is like the most boring building of all time. But they wanted a buff finish, probably to match the rest of the boring building, but also to prevent any kind of reflectivity going into their windows by using a bright white. So they went with that buff finish. It's a nice, clean finish. A hotel, same thing. They want little to no interruption. They want to keep their doors open, so they went with the self-adhered system. Put down that base layer, get your watertight, have all the other trades go up there, do their job, and then go ahead back and put down that top cap ply. Low slope roof, Sarasota High School, home of Orioles spring training. I know we'd all like to be there right now with the cold day we have. But bright white roof here. Bright white is the thing to do. They utilized a 3-ply self-adhered system, smooth base sheet, smooth mid-ply, bright white self-adhered cap sheet to top this off. This one here, a hospital, same situation as the first hospital. Lots of penetrations here. If you look closely at the penetrations on the picture on the left, they used a liquid flashing, which we talked about in previous slides. It's just a way to really bulletproof a tough system. Multifamily housing, North Carolina, this guy was insistent on having a green roof that would match his green standing seam. No one can see this green roof, so I don't know the reason for that. But if you come across a job that requires a green roof, a red roof, pretty much any shingle out there or any color metal out there, there are modified products that can match it. So that's about it. Do you guys have any questions for me? I'm going to stop sharing my screen, hopefully. All right, you guys there? This whole online thing is a lot less interactive, so it's a little awkward. But I will. You guys are welcome to ask questions. I do want to point out just a couple Polyglass products while the presentation is over. One product in particular. Our self-adhered systems in general is what we're known for. That's our baby. We invented it. Every manufacturer has one on the market now, but we hold patents to this day that no one else has. Pre-manufactured end laps, side laps. We have a great bright white SA product called Polyfresco. We utilize a film finish that we took from our parent company, Mapei, which you guys are probably familiar with Mapei. So Mapei is flooring and grouts, but basically we took this film finish from the automobile industry. So we have a bright white membrane. It helps with granule retention, and it stays bright white. I think the reflectivity is still 93 after 3 years, which is pretty impressive. And then we have a 1-part flashing grade product that we like to specify on almost all of our modified systems. And again, the reason for that is in those worrisome areas, they're no longer worrisome. So, and it's only a 1-part. So we're not asking the guys to be chemists on the job like a PMMA system would require. Any questions before I let you go to have big eats this weekend?
I have one just because I was, I had a waterproofing envelope consultant comment on a single-ply detail and say that they're starting to recommend like either a vapor barrier or something under the insulation, sort of on top of a metal deck.
Yeah.
I don't know if you've seen that before.
Yeah, so just during install, or are they just talking, they want a vapor? I mean, you can get
Yeah, I think they're thinking the thermal performance, you end up with some condensation landing on, like if you just have an exposed deck with no concrete, a steel deck there, I think they were expecting, you know, some condensation happening, you know, between the insulation and the deck and then creating degradation of the metal.
Yeah, so I have mixed feelings about vapor barriers because if you think about the construction in general, where is this moisture? It has to find its way out regardless, right? So we've gone on technical rants about this over and over again. So I can actually send you a follow-up email based on what our head tech guy says. But it's not a bad idea because I don't think anyone really has the answers at this point. So we have a vapor barrier, yes. In a lot of our construction, people will use our SAV, which is just our self-adhered base sheet. They'll put that down as a temp roof while construction is going on. So yes, it's a very common practice if that's what you're asking. Does it make a whole lot of sense? I can't confirm that.
Yeah, I don't know. Okay, thank you.
Yeah, no problem.
Does your roof allow any vapor drying out to the top above this vapor barrier?
Yeah.
Is there any vapor permeability to your roof to dry?
No. So, and that's what the issue with vapor barriers comes into play. Because when you have a vapor barrier that allows permeability, it's still going out one way or another, right? So when you're putting a watertight system, whether it's a TPO or a 2-ply modified system, your moisture is still somewhere. So we just have to assume that, you know, if you're really the biggest issue is concrete. If you don't have aged concrete, we don't even require, in Polyglass specifically does not require a vapor barrier in our concrete systems. What we require is that the concrete has to be aged for 30 days because that is where you see issues. I just frankly haven't seen any issues take place. If the concrete's aged, you put down your insulations, your insulation, your cover board, your system, you're good to go. We have not seen any issues with the non-permeable system. You have a watertight structure. Does that answer your question?
Yeah, that does. Could you tell me more about your liquid flashing system? And I personally have a preference to use the polyester with it, so that it's more flexible.
It's a great move, and we suggest it as well. So our product is called Polyflash 1C, and you can look it up, or I can send you guys a link to Danny, and he can shoot it out to you guys. But it's Polyflash 1C. It's actually a modified silane, which is like, think, if you're familiar at all with chemistries, think of like a silicone urethane mix. So what that means is you have an incredibly durable product that can withstand ponding water, that can adhere to almost anything because it has a really great bite. But also, unlike a standard silicone, you can coat over it. So if for some reason down the road you need to, you can. Whereas a standard silicone, it's extremely difficult to coat over. So what we suggest with our Polyflash 1C is a 1-part product that requires you to put down the product. It's like a caulk. I don't want to say super caulky, but it's more caulky. It's like a mix between a coating and a caulk. So trowel grade or a short chip brush will do the job. You'll brush in the product, you'll embed your polyester fabric, and then you will do a second saturation coat, and that's it. It is moisture curing. You have about a 30-minute pot life to put this stuff down. If it rains an hour later, you're totally fine. It's an awesome product. Who we're competing against, if you're using a Kemper system or a PMMA, of a 2-part urethane or a PMMA, well, those products require the contractor to know exactly what they are doing. We like to say we require them to be chemists on the job. And Polyglass used to have a 2-part urethane, so we know this well, and we know the issues that can come up. Hence why we came out with a 1-part. And yeah, that's what we push. We also, I will mention, we do have a full liquid system. It's Mapei bought a company that we, Polyglass, have inherited. We call it Polyproof. It is a urethane-based system, great for traffic coatings, garages, all that good stuff. So if you do come across a system, and traditionally maybe you're using a PMMA or something of that sort, we do have a comparable product that's about 1/3 of the cost, and it's fantastic. And the technology has been used all over Europe for many, many years, so it has a very nice long track record. Any other questions? All right. Well, I thank you guys very, very much for taking some time to meet with me today. If you guys have any questions at all, obviously our website, Polyglass, it's a great website. It can get you what you need, but please, please reach out if you have any questions at all. Danny, I look forward to you getting me the sign-in sheet whenever it's convenient. And thank you guys. Have a wonderful Thanksgiving.